All right, geometry students, welcome to chapter 2. And you can see we are going to be taking a look at angles and measurements in this chapter. Um, so a lot about angle relationships, and we'll get into that. It's something that's really important as we move forward through this class. And then we're going to talk about measurements, so we'll be focusing a little bit on units as well that go along with this, with whatever we're talking about. So if we take a look at lesson 211, what we're going to be looking at is what is the relationship of different angles. Specifically, we're going to look at complementary, supplementary, and vertical angles. So if you notice right here in chapter 1, you compared shapes by looking at similarities between their parts. For example, two shapes might have sides of the same length or equal angles. In this chapter, you're going to examine relationships between parts within a single figure. So we're going to be looking at angles in a single shape or a single figure in this chapter. Today we're going to start by looking at angles to identify relationships in a diagram that make angle measures equal. So as we take a look here, if we come down here to problem 2-1, they talk about a mirror problem. Okay, in order to see yourself in a small mirror, you usually have to be looking directly into it. If you move off to the side, you cannot see your image anymore. But Mr. Douglas knows a neat trick. He claims that if he makes a right angle with the hinged mirror, he can see himself in the mirror no matter what direction he looks at. So if you take a look at this angle right here, the mirror that they're talking about is this mirror right here. They're saying that right there is the mirror that he's looking into. And so as we take a look at that, what they're talking about in this problem is that it looks like this is his line of sight going right here. He's looking into the mirror. That bounces off of one side of a mirror, bounces off of the second side of the mirror, and then comes back to him, and it looks like he can see himself then. So if you notice, one of the things they talk about down here is what appears to be true about the line of sight. Well, they even have it right in here. If you notice, they've got some arrows in here. Looks like those two are probably parallel to each other. Okay, and that's something that we're going to take a look at is parallel lines and things along those lines. So let's go on to the next problem and see what we have here. In 2-2, notice, to completely understand Mr. Douglas's reflection trick, you need to learn more about relationships between angles. But in order to clearly describe relationships between angles, you need a convenient way to refer to them and name them. So this problem is all about naming angles and how we name different angles. Okay, so if you take a look at part A here, notice the top of this triangle is usually referred to as angle A, written as with angle A with the symbol in front. Okay, the top part here is the vertex, and so if we go through and we take a look at, let me go up here and go to a highlighter. So if we take a look, here is point A is called the vertex of this angle. Okay, so it's like the point of the angle, if you will. Let's see, let me go back to the pen. So since the measure of angle A of a degree, it's always written so that anytime you see this little m outside, that means measure of angle A. And since angle ABC is equilateral, we can write an equation showing the relationship. So the idea is, since this is an equilateral triangle, we also know that the angles are the same. So I could go through and write the measure of angle A is equal to the measure of angle B, which is also equal to the measure of angle C. Okay, so I know that that's a true statement. Then as we move into part B here, it says Audrey rotated triangle ABC around point A to form triangle AB prime C prime. She told her teammate Maria, I think the two angles at angle A have the equal measure. Maria didn't know which angle she was referring to and how many angles do we have. So one thing as we take a look at this, notice as you look at vertex A here in the picture, this vertex right here, we have, here's one angle right there. Here's a second angle right here. There's a third angle here in between, and then we can start to layer stuff. We can put these two angles together. There's a fourth one. We can put these two together. There's a fifth one. Or we could even come and put all three of these together, and there's a sixth different angle at vertex A. Okay, so that brings up one of the points that how do I know what to use, what to call each angle? And so the idea is if there's an angle all by itself, kind of like here, we've got angle B is all by itself right there, I can call that angle B. However, if there's more than one angle at a vertex, we need to use three letters. Like if you take a look at part C here, notice one of my angles is angle BAB prime. So if we take a look, angle B, and I just trace it, AB prime, I know that this is the angle we're talking about right there, okay? Because we use three letters rather than the one. And the key part is that the vertex of the angle is the one that has to always be in the middle, okay? I could have also said that this was B prime AB and written it backwards the other way. It would be the same angle. But the key part of this problem is recognizing that if an angle's by itself, like back up here in part B, okay, like we said, if that angle's by itself, you can use one letter. If there's more than one angle, like at angle A, then I need to use three letters. Okay, so keep that in mind as we move forward. So now we're going to take a look at some angle relationships. Okay, and so if we talk about some of the different types of angles. So what we're going to take a look at is, if you look at this picture, one of the things you know is you see the 90-degree angles. And so therefore, if you look right here, I'm just going to highlight this. Two angles that have a sum of 90 degrees are called complementary angles. Okay, and so therefore, if I were to go back through and we were going to, let me go back to the pen here real quick. If I were to go back through and it says here, if the measure of angle CBD, okay, that is this angle right here, if that's a 76-degree angle, what's the measure of angle ABC? And therefore, if you know that the total is 90 because of this right here, we can go through and take the total of 90, we can subtract the 76 that we already have, and whatever's left over, in this case, 14 degrees, and that's my answer for angle ABC. Okay, so those are complementary angles, two angles that add up to 90. If we then go to the next part, the next problem, now we take a look at two things that are called supplementary angles. So right here, if the sum of the measures of two angles is 180, they are called supplementary angles. Okay, so same exact idea as in part A, except we're adding up to 180 instead of adding up to 90. So on this one, notice they had said, it's also called a straight angle because it forms a straight line. Okay, so a line is always 180 degrees. So notice if the measure of angle LMP, if this right here is a 62-degree angle, the question is, what's the rest of it? Well, 180, the total, minus 62, the part that we already have, would give you 118 degrees, and that's what's left over. Okay, that's that angle measure. So those are two types of angles that we're going to take a look at. Complementary adds up to 90, supplementary adds up to 180. Okay. In part C, then, if you notice it says, now consider the diagram at right, which shows line AB and line CD intersecting at E. And they say if x equals 23 degrees, okay, so I'm going to put 23 degrees, find the measure of angle AEC, DEB, and CEB. Basically, find the other three angles. So if we notice, if this angle's 23, then I can find the rest of it, because if I put this whole thing together, it's going to add up to a straight angle at 180 degrees. Those two are supplementary. So that means if I take 180 minus the 23 that I already have, that means this angle will be 157 degrees. If I then go ahead and now take a look at the next part, well, this angle that I just found plus the next part, if I put those together, that would give me 180 degrees. So that means this one must be 23 degrees. Okay? And finally, if I do it one more time, we can take a look at the angle that I just came up with, and then the angle that's right next to it, that would give me 180 degrees, which means this is 157 degrees. Okay? So there's using the concept of supplementary angles. So if you know one, we can find the other three. Okay, so if we take a look, notice in part D, they said which angle has the same measure as angle AED. And as we take a look at that, notice that this angle right here and this angle right here both have the same angles. Okay, Well, as we take a look, those have a special name as well. They're not called supplementary, they're not called complementary. What they are called is, if you take a look at the next one, when two lines intersect, the angles that lie on opposite sides of the intersection point are called vertical angles, okay? So for example, those two angles that are 23 degrees, those are vertical angles. The two angles that are 157 degrees in that picture, those are also vertical angles, okay? So those are the three different types of angles that we're going to take a look at. Complementary add to 90, supplementary two angles that add to 180, and vertical angles are equal and are right across from each other when you look at two lines of intersection. So now if we take a look at the next problem. So it says here, Travis noticed that the vertical angles in C and D had the same measure. He wondered if that's also true for any other measure. So if we take a look, it says let's find angle CAB if x equals 54. So let's go back to our pen here and let's put that in here. So if x is 54 degrees, let me pencil that in here. And now if I do the exact same idea, we can do supplementary, we can do vertical, we can do all that kind of stuff. If I did supplementary angles, let's look at that first. So this angle along with that one, that whole total should add up to 180 degrees because you get a straight line. So 180 minus 54 is 126 degrees. If I do it again, this should also be 126 degrees over there. And then that means that this is 54 degrees right here. Okay, so very similar to what we did. Notice in part B, they say based on your observations, write a conjecture. Okay, and a conjecture, if you notice, is a statement. I'm going to underline this one. A statement based on an educated guess that has not been proven. Okay, so that you're going to start to hear the word conjecture. That's what it is. It's an educated guess that hasn't been proven. Okay, it's what you think. It's kind of like a hypothesis if you think about it in terms of science. Well, in this case, what do we think about vertical angles? And hopefully you came up with the fact that vertical angles are equal to each other. Okay, let's keep going. So now this problem, in problem 2.5, we are now starting to take a look at using our angles. This is kind of almost our check to see if we can do this correctly here. Okay, so what I want you to do is I want you to pause the video right now and try to do these 4 problems and see what you come up with. And then once you're done, come back to the video and check to see if you did things correctly. Okay, so if we take a look, you should be using supplementary, complementary, and vertical angles as your idea. Okay, pause the video, give it a shot. All right, welcome back. So if we take a look in problem A, we have 152 degrees. These two angles are supplementary angles, so that means they should add up to 180, which means if you take 180 minus 152, that leaves you with 28 degrees is left for that angle measure. Okay. In problem B here, they ask you to find the measure of angle FGH. One thing you need to notice is, and we haven't talked a lot about this in class yet, but notice those two markings. Those two markings mean that those angles are equal to each other. They have the same measure. And therefore, if they have the same measure, I can write an equation. I can say that 4x minus 5, that top angle, is equal to 3x plus 2, the bottom angle. Okay, those two have equal angles, and now I can go through and solve for x. So if I subtract 3x over here, those will cancel. Since I brought the x's to the left, I'm going to add 5 the other way, get that out of there. So I end up with over here, 4x minus 3x is just 1x. 2 and 5 give you 7. And notice, therefore, x equals 7. But if you take a look, was that what I asked you in the problem? And the answer is no. The problem asked you to find the measure of angle FGH, which means I need to take that 7 and plug it back in. So 3 times 7 is 21, plus 2 more. That means this angle is a 23-degree angle. If you wanted to check your work, you could plug it into the other one just to make sure it works. 4 times 7 is 28. Minus 5 also gives you 23. So sure enough, the two angles are equal to each other. Okay, so there's an example of congruent angles. If we come down here now to part C. In part C, This is an example of complementary angles because if you put those two angles together, we would get a total of 90 degrees. And that's exactly what we're going to do. We're going to put those two angles, we're going to add them together and know that the total must be 90. So we're going to go with 2x minus 4, one angle, plus x plus 7, the other angle, and those two, when we add them up, have to equal 90 degrees. Okay, those are complementary angles. And now we're right back to algebra again. Put the x's together. We have 3x. Combine your other like terms, the negative 4 and the 7. We have plus 3 equal to 90. Subtract the 3 over to the other side. Start solving for x. We get 3x equal to 87. And therefore, we divide both sides by 3. Give myself a little bit more room here. And what you should find out is that x equals 29. Okay, x equals 29 is my answer. But now, once again, if we take a look back up the problem, it didn't ask you to find x. It asked you to find the measure of angle DBC, which is the bottom angle. Okay, DBC. And so if I plug that back in, 29 plus 7 gives me an answer of that is a 36 degree angle right there. Okay, and finally our last one here in part D. Now we're looking at finding a couple of different angles. In this scenario, these two angles that are labeled with some algebra in it, if we add those two up, that'll give me a nice straight angle here. So that means that those two must add up to 180. So I know that x plus 28, if I put those two angles together, those are supplementary, so they should equal 180. Start to combine like terms, I get 2x plus 28 equal to 180. Subtract the 28 over, start to get x by itself. I end up with 2x equal to 152. Yep, I think that's right. And then we divide both sides by 2, and I find out that x equals, what do we get? 76. So once again, there's your value of x, but look back at the problem, what they asked you to find. They want the measure of angle LPQ and LPN, okay? So LPQ, that is this angle. There's L, there's P, there's Q. That's this angle that we're talking about, so we're referring to that angle right there. If I plug that back in, 76 plus 28 is 104. So that's a 104 degree angle. And then they want the rest of it, they want angle LPN. So we're looking for this angle right here, which you can either has to be supplementary to the 104, these two if we put them together, or it turns out that it's vertical with x, and therefore it also must be 76 degrees. Okay, so these are the types of problems that we're going to solve, at least at the beginning, where we're looking at supplementary, complementary, and vertical angles. Okay, if we take a look back here at our math notes box, this is basically a summary of everything that we talked about. Okay, it's a summary of this lesson, so you can take a look at that. Practice to learn for this problem, for this section is all of them, 2-8 through 2-12. So good luck on that. Hopefully everything made sense, and do the best you can. We'll see you in class.